Hi everyone, in this video I want to go over the sequences, the properties of the sequences, and important formula behind the limit of sequences. So the first formula is the limit of a to power 1 over n when n approaches infinity and when a is a positive real number. You may write it as limit of root n of a when n approaches infinity. This limit is equals to 1 when a is a positive real number. The second property is the limit of n to power 1 over n when n approaches infinity. So instead of a, which is a real number, the base here is n. Instead, it's a variable n. So it's limit of root n of n when it approaches infinity. This one also, it's equals to 1. In general, if you have a polynomial under the square root n, under the radical root n, if you have a polynomial and polynomial be with variable n, when n approaches infinity, this limit is equals to 1. And this formula actually is just generalization of the formula 1 and 2. Also, limit of a to power n when n approaches infinity equals to 0 if we know that absolute value of a is less than 1. It means that a it's between -1 and +1. So if a is between -1 and +1, then a to power n equals to 0 because, for example, consider 1/2. 1/2 to power 2, it's 1/4, and 1/4 is less than 1/2. And then 1/2 to power 3, it's 1 over 8. And 1 over 8 is less than 1 over 4, it's less than 1/2. As you see, the sequence is decreasing and goes to 0. It approaches actually 0 when n approaches infinity. And if absolute value of a is greater than 1, then limit of a to power n does not exist because it approaches infinity. So the next property is a limit of a 1 over n to power a when n approaches infinity, it's equals to 0. And in this case, the exponent a should be positive. So if the exponent is positive here, for example, 1 over n to power 2 when n approaches infinity, denominator goes to infinity and 1 divided by infinity, it's 0. Another formula, it's limit of a to power n over n factorial when n approaches infinity is 0 when a is a real number. Although when n approaches infinity, a to power n goes to infinity in some cases and n factorial goes to infinity, but the rate that n factorial approaches infinity is much more than the rate of an. So this limit goes to 0. Okay, now let's start working on some problems and find the limit for sequences. Consider sequence sine of pi times n half. We are looking for the limit of this sequence. What is limit of a n when n approaches infinity? It's equals to limit of sine of pi n half when n approaches infinity. If you plug infinity here, what happened? Infinity times pi half, it's infinity, right? So you have sine of infinity. What is sine of infinity? We don't know what is the sine of infinity. The only thing that we know is sine always it's between -1 and +1. So about the sine of infinity, we know that it's between -1 and +1, but doesn't exist actually because we don't know what is the infinity. So doesn't exist. How about if the question is sequence n squared plus 1 over n plus 1? What is the limit for this sequence? Let's find the limit. Limit of n squared plus 1 over n plus 1 when n approaches infinity. To find the limit, let's factor n squared from numerator. So the first term is 1 and the second one is 1 over n squared. In the denominator, the variable is n. So let's factor n. The first term is 1 and then second one is 1 over n. N approaches infinity. Now you can cancel n from numerator and denominator. You can divide numerator and denominator by n, and now the remaining is a limit of n times 1 plus 1 over n squared over 1 plus 1 over n, and n approaches infinity. Now, if you plug infinity, what you have? In the denominator, you have 1 divided by infinity, which is 0. 0 plus 1 is 1, so denominator is 1. In the numerator, you have 1 divided by infinity, which is 0, 1 plus 0, which is 1, and 1 times infinity, which is infinity. Infinity divided by 1, it's infinity. So the final answer is infinity. And this sequence diverges because the limit when n approaches infinity goes to infinity. Now let's find the limit of this sequence. 3 plus 0.6 to power n when n approaches infinity. When n approaches infinity, we have a limit of 3 plus a limit of 0.6 to power n when n approaches infinity. Limit of 3 is 3. How about limit of 0.6 to power n when n approaches infinity? You remember that there was a rule, limit of a to power n when n approaches infinity is 0 if absolute value of a is less than 1. 0.6, it's between -1 and +1, And um, so the limit when n approaches infinity is 0 because zero point 0.6 to power n it's decreasing and approaches 0. So it's 3 plus 0, which is 3. The next sequence, let's suppose that we have the limit of natural log of n to power 3 divided by n when n approaches infinity. How we can find the limit of this sequence? There is a rule for natural log. We know that natural log, limit of natural log of n divided by n when n approaches infinity, it's equals to 0. So, based on that rule, limit of n divided by n when n approaches infinity is 0. Can I say that the answer here is 0? When you look at the question, in the numerator, instead of natural log of n, there is natural log of n to the power 3. It's not natural log of n. But we know that for the logarithmic function, log of a to exponent b, it's b log of a. So I can write the problem as limit of 3 times natural log of n divided by n when n approaches infinity. Now, by using the rule limit of natural log of n divided by n when n approaches infinity is 0, then 3 times 0 is 0. So I can rewrite it as 3 times limit of natural log of n divided by n when n approaches infinity. So it's equals to 3 times 0, which is 0. The next sequence is 1 minus 1 over n to exponent 4 n. We are looking for the limit when n approaches infinity. How we can find limit of this sequence? There is a rule, limit of 1 plus a divided by n to power n. When n approaches infinity, it's equals to e to power a. I want to use this rule to answer to this problem. Here a is a real number. A real number can be positive and negative, right? And we have 1 plus a divided by n. But here it's 1 minus. So let's rewrite the question. I can rewrite it as limit when n approaches infinity, 1 plus negative 1 divided by n to power 4n. And the next step is here in the formula the exponent is n, here is 4n. So let's rewrite it. I can rewrite it as 1 plus negative 1 divided by n to power n and then to exponent 4 when n approaches infinity. Now by using the rule inside the limit of inside, it's equals to e to exponent -1, and then I have exponent 4. So it's e to -1 to exponent 4, and it's equals to e to the power -1 times 4, which is e to the power -4. You may write it as 1 over e to the power 4. The next type of questions for the sequences, it can be polynomial in the numerator and another polynomial in the denominator when n approaches infinity. We want to see if this sequence converges or diverges. If there is a polynomial in the numerator and another polynomial in the denominator, definitely the approach should be factor the most degree of numerator, factor the most degree of denominator, simplify, use the rule, and find the final answer. So I do these steps. I factor n squared, so the remaining is 1 minus 3 divided by n. In the denominator, I factor n squared. The remaining is 3 plus 2 divided by n squared. N approaches infinity. Now we can divide numerator and denominator by n squared. The remaining is limit of 1 minus 3 divided by n in the numerator and 3 plus 2 divided by n squared in the denominator when n approaches infinity. When n approaches infinity, 2 divided by infinity is 0, 3 divided by infinity is 0. So numerator is 1 and the remaining in the denominator is 3. The final answer is 1/3. But there is another way to answer the question. If you don't need to show your work and take all the steps, let's suppose that the question is multiple choice and you need to just say the answer is 1/3. If there is a polynomial in the numerator, a polynomial in the denominator, you look at the degree of numerator. Degree of numerator is 2. What is the degree in the denominator is 2. If numerator and denominator have the same degree, when n approaches infinity, the answer is the leading coefficient of numerator divided by leading coefficient of denominator. So it is 1/3. How about the next question? What is the degree of numerator? Degree of numerator is 2, but degree of denominator is 1. So they don't have the same degree, and that rule cannot be applied here. So what should we do? Definitely we factor n squared from numerator and from denominator we simplify. But the rule here is if degree of numerator is greater than degree of denominator, when n approaches infinity, the answer is infinity and sequence diverges. How about if the degree of numerator is less than degree of denominator? When n approaches infinity, if degree of numerator is less than degree of denominator, the answer is 0 and converge to 0. The reason is that in the denominator you have n and n approaches infinity, so the answer is infinity. In the numerator, after simplification, you have just a constant divided by infinity, it's equals to 0. Okay, this is all about the sequences and limit of sequences. See you in the next video.